We're going to start recording the session. So this Friday there is a grand opening for Mission Del Paso, and therefore we're not going to meet in the class. Oh, we're not going to meet at all. We're almost done with the semester. We're almost done with the syllabus that we're supposed to cover. We have 2 more sessions. We do those next week. Okay? So today, let's go ahead and do 1 session. We'll finish it, and we'll be left off with 2 more sessions. So today, we're going to be talking a little bit about probability distribution. So before I start probability distribution, is there any questions on what we covered so far? No? All right, so let's go ahead and talk a little bit about probability distribution. What do we mean by probability distribution, and how do we make a probability distribution table? So first, let's talk a little bit about what we call a random variable. A random variable, let's call it x, is a function that assigns a real number to each outcome of an experiment. So if we do an experiment, a random variable will assign a particular number for each outcome of the experiment. Yes? So let's say we're going to do an experiment of rolling a die. Yes? We can assign x. X would be the face value on the die. The face value that shows up when we roll a die. Yes? So to do a probability distribution, we're going to consider what x is and what face value we're going to see. So what are the face values to see on a 6-sided die? We could see a 1, but also see a 2, 3, 4, 5, and 6. So those are the values for x we can assign for this particular experiment. Yes? Now, the probability of x means we're looking at the probability of each value that shows up. What's the probability of that value showing up? So in this case, for instance, to show 1, it is 1 over 6. Yes? Or in this instance, all the values are simply 1 over 6. Yes? In a probability distribution, the sum of all the probabilities given would equal to 1, must equal to 1. Yes? So another way, if I would add all of these together, I should get a result of 1. None of the values should be less than 0 or greater than 1. If these conditions are met, then we call that a probability distribution. Yes? So if I have a distribution, for instance, say, for whatever distribution, and those numbers are, say, 0.1, 0.5, 0.2, 0.3, and so on. In order to call this a probability distribution, we want to make sure that all the values are greater or equal to 0, but less than or equal to 1, yes? And all of these values are. We also need to know to make sure that the sum of all these values add up to 1. If they don't, then it's not a probability distribution. So based on that fact, 0.3, that's 0.5, that's a 1, that's 1.1, this is not a probability distribution. Yes? We could, however, be a little bit off a little bit off. When I say a little bit off, not due to the probability distribution, but due to the rounding. Sometimes when we round in a number, we may end up with, let's say, a probability distribution of 1.001. That is maybe acceptable, depending on how you round it. Yes? This could be a rounding error. Unless it is not a rounding error, unless it is a rounding error, then it has to be 1. Yes? So this is not a probability distribution, but this is, because the sum, it follows the conditions for having a probability distribution. Okay. So for instance, let's go ahead and do another probability distribution. Let's say, let x be, let's say, toss in 2 coins, and let x be, x is the number of heads that you see. When you toss 2 coins, we're going to consider a probability distribution for x being how many heads do I see when I toss 2 coins. Yes? Let's take a look at all the possibilities we have. When you toss 2 coins, how many heads could you see? What's the first option? What could those 2 coins be? What could you see on those 2 coins? You could see head, tails, right? What are the possibilities for heads? How many possibilities do I have? You could have at most how many? 2. What is the minimum you could have? Let's start with the minimum. What's the minimum you could have? You sure one? 0. Because both of the coins could be tail, right? In this case, you don't see no head, so minimum is 0, right? What's after that? You could also see 1, yeah? And you could also see 2. Both coins be heads, yes? So this is all the possible values for x from this particular experiment. Yes? So now let's talk a little bit about the probability of each one. Probability of each one, we need to know a little bit about the sample space that we're looking at. Yes? So if I look at the sample space for this particular experiment, what are the sample space? Another way, what are the possible outcomes I could have from this particular experiment? The 2 coins could be both heads. Yeah? Or the first coin is a head and the second is a tail. Or we could also have tail and a head, or we could also have 2 tails. Yeah? So now the possible outcomes for that sample space is 4. That's all the possible outcomes we could have. Yeah? And out of those outcomes, what is the probability that the number of heads I see is 0? And I'm going to look over here and see how many of those outcomes give me a 0 heads. This one gives me a 0 head, right? Any other? No, there is only one that gives me a 0 head out of how many? Out of 4. So the probability for getting 0 heads on the toss is 1 in 4. 1 out of 4. Or 1/4. Yes. What is the probability of getting 1 head? Let's take a look at the sample space. How many options do I have for getting 1 head? 2 options, right? We can have a head and a tail, or tail and a head, right? So there are 2 options for that. So in this case, the probability of getting one head is 2/4. Now, what's the probability of getting two heads? 1/4. So now, the probability distribution for tossing a coin and determining how many heads you have is that. Now notice, if I were to add all of these numbers are numbers between 0 and 1, yeah? And if I were to add all of these numbers, I get 1. So 1/4 plus 2/4 is 3/4, plus 1/4 is 4/4, and 4/4 is 1. Clear? Let's take a look at another probability distribution. Maybe we can have a better understanding on that. Let's say we roll in two dice. And then X is the sum of the phase values. So X being the sum of those phase values. When rolling two dice, X being the sum of those two values. And it says, draw a probability distribution for X. So first of all, we need to know what values do I get for X by rolling two dice. We have to put all the possibilities together in order to determine what numbers I get. Yes? What number could you get? And let's start from the lowest to the highest. What are the numbers you could get? We could get a 2. Both of the dice are 1. Yes? What else we can get? So we can get all the numbers between 2 and how much? And 12. Yeah? So let's write them down. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So once again, last time I did talk a little bit about how many ways you can get each one of those, right? We said on the 2, we can get it one way, right? That's the only way. And then the numbers start going up by 1, right? All the way until we get to 6. And when we get to 6, the numbers start going down by 1. Yeah? So let's write them down. So there are one way of doing 2, 2 ways of 3, 3 ways of 4, 4 ways of 5, 5 ways for 6, 6 ways for 7, and then 5, 4, 3, 2, 1. So these are all the possible ways you can get each of those numbers. Okay? Any question on that? How many possible outcomes are there on rolling two dice? A little more than 12. If you remember correctly, let's go back. How many outcomes do I have on rolling one die? 6.
36.
And the other one is also what? 6. And we multiply these two, we get 36. So we do have 36 possible outcomes. Yes? If you're not sure, you could have added all of these outcomes over here. Yes? And those will give you 36. Okay? So now let's go ahead and do that. So what's the probability of getting a 2? We have only one possible way, right? We have 36 different ways. So that's going to be 1 out of 36. So this is the probability of X. Probability of X. How about this one? 2 over 36. Yeah? How about this one? 3 over 36, 4 over 36, 5 over 36, 6 over 36, and then 5 over 36 again, 4, 3, 2, 1. Yes? To make sure, let's add them up. All the denominators are 36. We cannot simply add the numerator, right? So 1 and 2 is 3, 3 and 3 is 6, 6 and 4 is 10, 10 and 5, 15, 15 and 6, 21, 21 and 5, 26, 30 with a 4, 33, 35, 36 over 36, that's one. Yeah? So now what can I do with this probability? Let's say we're looking at the probability x is greater than or equal to none. What does that mean? Means the sum has to be what? Could be greater than or equal to none, right? How many numbers do I have the sum greater or equal to none? How many of them? Where are they? Which ones are they? 9, yes? 10, 11, and what? 12. So this is equal to the probability of x equal 9, probability of x equal 10, probability of x equal 11, probability of x equal, say, 12. When we say greater or equal to none, that's exactly what we're saying. We want to add all of these probabilities together. So then, at 9, we said it is how much? 4 over 36 plus 3 over 36, 2 over 36, 1 over 36. And 1 plus 2 plus 3 plus 4 is 10 over 36. Yeah? We can look at any probability we want. Say, for instance, probability x is between 5 and 7. What is that probability? What am I looking for? I'm looking at the number of x being between 5 and 7, right? So this is, do I include 5? Yes, because it says equal, right? So the probability of x equal 5, probability of x equal 6, probability of x equal 7, you get those numbers, you add them up, and that will be your probability. And you already have the probability distribution right here. You can just pick each one. 4 over 36, 5 over 36, 6 over 36. That will give me 15 over 36. Yeah? Any questions on that? So that's how we determine what the probability distribution is for any kind of experiment. Again, we have to study all the scenarios for that particular situation. Yes? And if you're not sure, make the experiment and see what you end up with. Okay? Expected value. When we're looking at the expected value of a particular scenario, we're looking at the average basically. We're looking at the average. Yeah? So if you're playing a lotto, your expected value is what your average of win. Okay, and so on. An expected value, how do I determine that? Suppose X consists of n values, say x1, x2, xn. Notice we just did the roll in a die, and the x value happened to be 6 values, right? From 1 to 6. So I don't know how many values I'm going to get for x, but let's say there are n values, whatever they are. Yeah? And the probability are P1, P2, Pn. For each x value, let's say it has a certain probability. Well, probability of x1 is P1, probability of x2 is P2, and so on. Yeah? So now we say the expected value of x, or the average value, would be x times P1, x1 P1, plus x2 P2, plus x and Pn. Where we take all the values and we multiply them by their corresponding probability. Yeah? We do that, that means this is the expected value, or this is the average for that. So we could have done that for the coin, we could have done that for rolling a die, right? Where x would be whatever. So by rolling a die, we said x is 1, 2, 3, 4, 5, 6, and then we had 1, 6, 1, 6, 1, 6, 1, 6, 1, 6, 1, 6. That's the probability of each one. So the expected value of x would be taking the value for x and multiplying it by its probability. So that will be 1 times 1, 6, plus 2 times 1, 6, plus 3 times 1, 6, plus 4 times 1, 6, plus 5 times 1, 6, plus 6 times 1, 6. So what we do? Take the value of x1, the probability is 1, 6, we multiply it, right? And so on. Yeah? So we have 3, 6, 10, 15, 21. So the average value is 21 over 6. Yeah? Or we could say it is 7, 3. So that's the average value for that, or expected value for rolling a die. Let's take something that we might use. For instance, suppose at a concert they sell in a raffle ticket. Suppose at the concert they sell in a raffle ticket. And on the raffle ticket there is a prize you could win. You could win say a box seat that is worth $400. You could win a box seat that could worth a $400. By the way, when you go to concert, they have boxes where you can bring your family and sit in there, whoever you want in that box, and you pay $400. You could also win a dinner, say, for 2, and that dinner worth $100. So you could win a $100 dinner for 2. Or you could win a CD that is worth $20, and there is two of those prices. So with the raffle ticket, you could win any of these prizes. Yeah? There's only one of each. Yeah? It says, what is the expected value of winning for a person who buys one ticket in the raffle? So first, let's say the company has made 2,000 tickets at $1 each. So what is the expected value of winning when you buy $1 ticket? And what does that mean? Okay? So first we need to make a probability distribution table. Yeah? To make that probability distribution table, we need to look at all the possible outcomes from buying one ticket. Yes? When you buy one ticket, so let's go ahead and do the sample over here. When you buy one ticket X, yeah? Let's say we need to know the value of that X, yes? When you buy one ticket, you could either win or lose. Any other option? But if you win, you have several options for you to win, yes? You could win a box seat, yes? In terms of money, how much money would you win if you won a box seat? Is it 400? Technically, you paid $1 for that one. So you didn't win 400, you won $399. That make sense? Yes? So we have scenario number one. You could win $399 for that ticket. What's the probability of you winning that ticket? How many tickets are there? 2,000. There is only one winning ticket, right? So the probability for winning that is 1 over 2,000. Yeah? Okay. Dinner for two. You could also win a dinner for two, right? And how much would you win? $99, right? How many tickets are they giving away, or how many dinners for two are they giving away? One. So that means only one ticket is going to win. So what's the probability of winning that? So you have the same chances of winning the box as well, right? What is the third prize? A $20 CD, correct? All right. If you win the $20 CD, that means you won $19. How many CDs are they giving away? Two of them. So the possibility or probability of you winning that will be 2 over 2,000. So far so good? Yeah? What's the last choice? That's all the winning you could have, right? What's the other choice? You lose? What do you lose if you lose? Up top. So since we're talking about winning is a positive, yes, then losing would be negative. So what's the probability of you losing? Well, how many tickets are giving away? 2,000. How many tickets are going to win? 4? Yes? How many tickets are losing? So the chances of you losing is 1,996 over 2,000. Does that make sense? So now we look at the expected value. So now we have If we were to add all of these, we end up with 1. Yeah? Because 1 plus 1 is 2, plus 2 is 4, plus 1996 is 2000. 2000 over 2000, that's 1. So now we have a probability distribution. Now we can find the expected value for that probability distribution. So what is it? It says the expected value is the value of x times the probability. Yeah? So that's be 399 times 1 over 2000 plus 99 times 1 over 2000 plus 19 times 2 over 2000 minus 1996 divided by 2000, and that's multiplied by 1, right? Because the value you lose is 1. Yeah? So now this is equal to negative 0.73. That's negative 0.73. So on average, a person buying a raffle ticket would lose 73 cents. Or person selling the raffle ticket will make 73 cents on the average for each ticket. Depending on how you're looking at it, from which perspective. Yes? Any questions? No? All right. Let's say another scenario. Let's say you and your buddy go together to work every day. You and your buddy go together to work every day. On your way, you buy a cup of coffee, both of you. Yes? Now the coffee cost $1.75. The coffee costs $1.75. So what you do is, instead of deciding who's gonna pay for it, or one person is gonna pay for it, you play a game. And that game is toss a coin. So one tosses a coin and one calls it. Yeah? If he calls it right, he wins, you pay. If he calls it wrong, he loses, you pay. He pays. Yes? So what is the expected value for that scenario? So first, to figure out the expected value, we have to make a distribution, yeah, probability distribution to see what is your chances of winning or losing and all of this. Now, technically, this is just a simple experiment. We could have done it 50-50, and we could say, well, it's a 50-50 chance, so therefore, your expected winning or losing is 0. Expected value is 0. But I just want to go through it so we can look at, from this, we can have the big pictures. Yes? Let's look at all the scenarios, just to go ahead and explain. So we have two things happening. First, somebody is tossing a coin, right? We have a result of that tossing a coin. And then somebody is calling it, and there is a result of calling that coin, correct? So let's go ahead and put that. Okay, so we have tossing a coin. And we have call. Yes? And based on that call, we have either result, win or lose. Yeah? Let's take the scenarios one at a time. So when you toss a coin, you get a head, let's say. The person who's calling before you toss could have called a head, yes? If he had called a head, right, then you win. Simple as that, right? But he could also have called a what? He could have called a tail. And if you call the tail, then you lose. So once again. But then the result could have been a tail. The result could have been a tail. And before you draw tail, he could have called head, and then he wins. And he could have called the tail. Oops, I put it backwards. He would lose here. Or he could have called the tail, and then he wins. So far, so good? Yes? Now, let's go ahead and do the probability distribution. In the probability distribution, so we have X. You have a win or lose. Do you have any other option? So let's go ahead and say win, lose. What happened when you win? How much do you win? A cup of coffee. The price of that cup of coffee. Yes? But if you lose, how much do you lose? Yeah? So now what's the probability of X? Win. Notice how many scenarios we have. We have a total of 4 scenarios, correct? How many of those scenarios are wins? 2. 2 out of 4 is 1/2. Yeah? And how many scenarios do you lose? 2. That's also 1/2. So now we know how much you win. What's the probability? So the expected value in this case is 1.75 times 1/2 minus 1.75 times 1/2. That is equal to 0. So in this particular scenario, the expected value is 0, and that's a fair play. Either you win or lose, unless the coin is not fair. It's not a fair coin, then, and you know that, but your buddy doesn't know that, then you cheat. Because in an unfair coin, head and tail don't have to have the same probability. For example, 1/3 of the time could be head, but 2/3 could be tail, depending. Or if a coin is a 2 head or 2 tails, then guess what? The other option never gonna happen. Yeah? So this is talking about fair coin with a fair probability. Yes? Okay, let's do one more example and call it a day. Roulette wheel. Everybody familiar with the roulette wheel? It's a wheel, of course. That's why they call it the roulette wheel. And on that wheel, there are some kind of slots. Right? I'm not going to put all of them. There are totally about 38 slots. we have 38 slots on the roulette wheel. And two of those slots, let's say this one, has a mark of 0, the other one has double zeros. The rest of the slots are 18, say red, and 18 black. So we have 18 red and 18 black. If you bet $1, let's say on red, if you bet $1 on red and you win, you get your dollar back plus another dollar on top of it. Yes? And if you don't get a red, you lose your dollar. Okay? So what is the expected value of winning? Of betting? So the expected value of betting $1 on red. Yes? The expected value on betting $1 on red. Again, we want to do a probability distribution. Yes? That probability distribution is x, then P of x. Yeah? And I'm going to put the scenarios you're going to get, and on top of it, what you're going to win or lose. Yeah? So how many options we have? You can land on red, you can land on black, you can land on double zeros, or you can land on 0. Yeah? So let's take scenario number 1. You landed on red, you win $1 because the other dollar, the one is you paid. Yeah? You win $1. What's the probability then of landing on red? Well, we have 18 red and a total of 38. So that's 18 over 38. Yeah? Well, you could also land on black. And in that case, you lose $1. And the probability of that is 18 over 38. Yeah? Or it could land on the 0. You lose $1. That's 1 over 38. Or it could land on a double 0. You lose $1. It's 1 over 38. Yes. Now we could have done it either win or lose. Yeah, either win or lose. But I'm just explaining everything step by step in all the steps. That's okay. Just in case we had a scenario where we have to really separate every item. So now what's the expected value? So we can say E of x is 1 times 18 over 38, that's your winning, minus 1 times 18 over 38, minus 1 times 1 over 38, minus 1 times 1 over 38. Yeah? So we're going to take every scenario, probability times the value, probability times the value, probability times the value. Those two cancel out. So the expected value is negative 2 over 38, which is negative 1 over. So the expected win for a person betting on red will be actually a loss of negative 1 over 19 of $1 every time. So another way, every 19 bets, he basically loses $1. For every 19 bets, he loses $1. Okay? And of course, for black, it's the same thing. Of course, for 0 and double 0, depending on how much money you win on each scenario. Yeah. Any questions? All right. I think that's it for today.